Hey everyone, welcome to day 3 of our Python class. So today we're going to be covering the for loop in Python. And the for loop is one of the most powerful loops in Python for a variety of reasons, but we'll get to that in a second. But before we even start talking about it from a Python perspective, I wanted to kind of talk about it from just a general perspective. So when we talk about for loops in Python or just loops in general, you really don't need to do any coding to understand them. And I see a lot of people get confused when they start learning about loops and they start learning about functions and other things because they don't understand the principle behind what's going on. They just see the code and they don't make the connection. So before we do any coding, we're going to talk about how a for loop in Python works in general. So in the day 3 instructions, I use a basket of fruit to demonstrate. And that's exactly what we're going to do. So with our basket of fruit, pull it over here so you can see it. We've got 3 fruits in our basket: an apple, a banana, and a pear. And what I say is, what I want you to do is for each fruit, take it out of the basket and say its name. You'd start with the apple, you'd take it out of the basket, you'd say apple, you'd put it aside. You'd take out banana, you'd say banana, and you'd put it aside. And then you'd take out the pear, and you would say pear, and you'd put it aside. Well, in Python, our basket looks like this. Uses square brackets. Each of the fruits would be in quotes. Now, we talked about tuples at the very beginning of the class. It was one of the first data structures we touched on. Now we're talking about lists. Lists and tuples are very, very similar. One of the few differences is lists can be mutated, which means they can be altered, whereas tuples cannot be. But really, that's more complicated than you need to worry about. Just know that a list is very similar to a tuple in that it holds multiple items. Lists are always ordered, same way that tuples are. So apple will always be in the 0th index, banana will always be in the 1st index, and pear will always be in the 2nd index. So now that we've kind of talked about looping a little bit, and you understand that when I tell you do something for each item in a basket, and you physically take each item out in order and do something with it, let's talk about how Python works in code, because it's exactly the same way. So we're going to start our Python interpreter by typing Python and pressing enter. I'm going to add our fruits to our interpreter. So I'm going to just copy this. There we go. So now we've got our list of fruits. This is a for loop, for fruit in fruits. This is how you're going to see it written over and over and over again. For those of you who have done Python before, or who have done other programming languages before, this will look totally different. Usually you have to keep track of an index. So in Java, it's for int I, while I is less than I++, all that stuff. Similar with C++ and C# and all those languages that require an iterator. Python is awesome because we can use this in keyword. And this makes our loop super readable because for fruit in fruits sounds pretty similar to, hey, for each fruit, do this. We're just replacing each with in. And then underneath our for fruit in fruits, we're going to print fruit. And that's exactly what I'm going to do. I'm going to copy this text. Here we go. Paste it in there. Press enter twice. And we're going to get each of our fruits printed out. So it does exactly what we expected it to. It took the first item, that's our apple there. It removed it from our basket. It printed the word, and it set it aside. Then it takes the banana out, prints the word, sets it aside. Pear, prints the word, sets it aside. That's all there is to a for loop in Python. But we aren't even scratching the surface of what a for loop is capable of. Now let's get a little more complicated. So sometimes you don't just want the word or the item in the list itself. Maybe you want to know what position the item is in. We can do this using the enumerate function. So I'm on step 3. All I'm going to do, I already have my fruits variable, but I'll go ahead and reinitialize it here. There we go. Is replace our original for loop for fruit in fruits with this structure for index, comma, fruit in enumerate fruits. So what this is doing for us is saying, hey, for not just the fruit, because up here we did for each fruit in fruits. The value of fruit got assigned to apple and then banana and then pear. For each fruit and its index, And I'm using a comma here to assign two variables at once. So for index, comma, fruit, in enumerate fruits, we're going to print fruit, fruit is at index, index. So let's do it. Here we go. Copy my print statement. There we go. And we get back fruit apple is at index 0. Fruit banana is at index 1. And fruit pear is at index 2. And that's exactly what we'd expect, because if we look at our list, apple is in position 0, banana is in position 1, pear is in position 2. I can make this a little clearer by showing you what's actually happening behind the scenes. So when we type enumerate fruits, just without a for loop, we get back this enumerate object. And an enumerate object is not very helpful just from a regular user perspective. There's not much I could do with this, but I can turn it into a list. Let me show you what that looks like. I'm going to say list enumerate fruits. And remember, a list is just this, right? So let's see what happens. So what we get is a list of tuples. We know what a tuple is. A tuple is just a collection of items in order, and a list is a collection, or this list is just a collection of these tuples. The first tuple contains the position of the item that's in the first position of this tuple. So it says it's in the 0th position, and the item itself is apple. The second tuple contains the position of the second item in our original list, which is position 1, and it's banana. Same goes for the third item in our list, contains the position of the item and the item itself. If I were to try to assign index, comma, fruit to the first tuple in our list, what do you think would happen? I'll give you a hint. Nothing interesting. It just does it, because index, comma, fruit, any comma you put in here, just takes the first variable you've listed and assigns it to the first item in our iterable, and takes the second item and assigns it to the second item in our iterable. So we can kind of compound create variables this way using commas and tuples or lists. So that's what's happening behind the scenes. Enumerate creates these lists of tuples, each of these tuples representing the index and the object itself that's in the list, and then the comma just assigns each variable to each item in the tuple. Bringing it all back together, for index, comma, fruit in enumerate fruits, print the fruit and its index. So enumerate will help you split apart these more or lists that you need to access the index of. But why is this useful at all? Why do I need to know the index? If I can access each of the items in my list, why do I care what position they're in? Well, sometimes we need to modify the items in a list. For example, if we're validating whether the first item is correct, let's imagine you're making a shopping list, right? Maybe you don't want apple to show up in your shopping list, and you loop through all the items in your shopping list to find out if apple is there. When you find apple, you don't want it. You want to replace it with apricot, because you don't need apples. You need apricots. In fact, let's do that. So I'm going to have you print out the original list. Here we go. Our original list is fruits. So our original list is apple, banana, pear, right? Nothing's changed yet. Now we're going to construct a kind of complicated for loop. Again, we're going to use this enumerate function. So for index, comma, fruit in enumerate fruits, we're going to print first that same sentence we used up here. So we're going to say print fruit is at index, index. So for apple, that'll say fruit apple is at index 0. For banana, that will say fruit banana is at index 1. You get the idea. Then we're going to say if fruits at index. So we're saying if fruits at the index. So remember I said you can use the index to reference the position of an object inside its list. Fruits is our list, and we're saying, hey, grab the fruit that's at position index. So if the fruit at position index is apple, equal apple, let's do something. The first time we go through this loop, the 0th item, the 0th indexed item will be apple. So fruits at 0 should be equal to apple. Let's replace our apple. We don't want apple in our list. We want apricot. There we go. So instead of saying fruits at index equal apple, so instead of fruits at index being equal to apple, we're going to say fruits at index is now single equal to apricot. So we've reassigned the item at that position in the list. What's interesting to note is this will overwrite the value of the original list. We are modifying the list itself. Sometimes this is not what you want, and in that case, you'd want to use tuples because we can't do this with a tuple. In fact, I'll show you that in a second. But what's important to know is that we're changing the list itself, so we are mutating it. Then, after we've modified that, we're going to print this out and say, here we go, fruit is still fruit, but fruits at index is now position index. So what I'm going to show you here is that this variable, fruit, for index comma fruit, does not change, even if we modify the value that is in the list at the position of this fruit. I'm just going to press enter and show you the results because it's a lot easier to explain when we get this printout. So we go through the list once, right? So we go through the loop once for index comma fruit and enumerate fruits. Print fruit is at index. Fruit apple is at index 0. That's exactly what we'd expect, right? Because our fruits go apple, banana, pear. Then we do our modification. And all of a sudden, fruit is still apple. So fruit is still fruit. That variable doesn't change. But apricot is at position 0 now. So fruit is still fruit, but fruits at index is at position index. So our fruit in the list changed, but our fruit variable did not change. So we can modify the list without modifying that variable. Now, because our next one, fruit banana is at index 1, is not equal to apple, this will not change anything. Fruit is still banana, but banana is at position 1 now. Nothing changed. Same with pear. Fruit pear is at index 2. Fruit is still pear, but pear is at position 2 now. So after our if statement executes over banana and pear, nothing changes. But when it executes over apple, fruit remains apple, but position 0 of our fruits list is now apricot. Okay, so we've executed this for loop, but check this out. When I type fruits and press enter, apple is gone. We've changed this list. We can't get it back either. This is fundamentally a different set of values. So let's talk a little bit about what a tuple would do this, because I mentioned earlier you can't do this to a tuple. So I'm going to make a list of better fruits, and I'm going to make a tuple. I use parentheses to make a tuple. Oops, there we go. Don't press enter. And I'm going to give our list of better fruits. We're going to go grapes, oranges, and pineapple. If I can spell pineapple. There we go. All right, so there's our better fruits, right? Better fruits. Okay, so I'm using the code that I showed you before, where we said fruits at index is equal to apricot. Check this out, right? So here's our original list, fruits, and I can say fruits at 0, which is apricot, I can press enter and get that, equals apple again. And if I type fruits, I get apple, banana, pear. Don't paste that in. There we go. Let's try that with better fruits. Better fruits better fruits at 0, let's do this first, is grapes. And let's say better fruits at 0, I want that to be apricot. Because, that's apricots, sure, better than grapes. Press enter. There we go. We get a type error because tuple objects do not allow you to modify the original list. We'll get a type error. Tuple object does not support item assignment. I cannot assign a new item to that position. So that's how your first exposure to an immutable data structure versus a mutable data structure. Now, some people will tell you should only be using tuples. You should never be modifying the underlying data. You should always be making a copy and changing it from that copy so you never lose the original data. And that's somewhat fair because when we modify our list, there's no history of changes necessarily. our list has been changed and we can't get back the original result. A tuple protects you from that. It prevents you from unintentionally modifying your data. So you have to make a decision based on what's best for your scenario. But in this case, since we did want to modify the original list, a for loop gives us that index. We can modify it. Okay. Next, I want to talk about dictionaries. We talked about dictionaries at the very beginning. Just as a concept, we wrote a vocabulary dictionary where you could give it a word and it would return back a definition. And we're actually just going to bring that same dictionary back. So I'm going to go ahead and copy over here, paste it in. It's the same vocabulary list we had before. So we open with those curly braces. We give it an apple. We give it the definition of an apple. We give it a banana. And we give it the definition of a banana. So we'll press enter. Vocabulary is now stored as a variable, and I can access it like that. And we want to, for example, access every element in the dictionary. Sometimes this is super useful because you want to go through the dictionary and check each value, or you want to go through the dictionary because you're not sure what values are even in there. You need to see them before you can do anything with them. So let's do that. Let's use a for loop to go through our vocabulary list. And fortunately in Python, it's really, really easy. All I have to do, I'm actually going to copy it from over here, is for word in vocabulary. So for each word in, again, we're using that in keyword, vocabulary, which is our dictionary, let's print the word. And if I press enter twice, you'll notice I get apple and banana. Interesting thing to note here, we're not getting the definition back, we're just getting apple and banana, which are our two vocabulary word keys in our dictionary. So when you do for something in a dictionary, it returns the keys of that dictionary. But this is really useful for us because in much the same way, we could use enumerate to get the position of an item in a list that we were looping through. We can actually just shortcut in a dictionary because this is the index in the dictionary. Apple is the index of our definition of an apple, and banana is our index of the definition of a banana. So we can access that index using our square bracket notation here. So let's do for word and vocabulary, print vocabulary at word. Press enter, and look at that, we get the definitions. So instead of the words, we've now accessed the definitions of those words. Okay, so we can access the definition of the word, we can access the words. Let's access both at the same time now. We used enumerate to access the position and the value in a list. We're going to use items to access the index and the value for a dictionary. And the way this looks is like this. For word, comma, definition in vocabulary.items. This .items turns our dictionary into a list object. In fact, before I even run this, let me show you exactly what this looks like. If I run vocabulary.items, I'll just copy this. There we go. We get this odd looking dict items thing with open parenthesis, but look at this, it's a list of tuples. There we go, you've seen this before. There's our square bracket starting the list, and then we have a tuple with the index, which is apple, as the first value, and the value, which is the definition, as our second value. It looks exactly the same to enumerate. The difference is we use the .items function in order to get it. So let's go back to our for loop. Here we go. Paste in our for loop. Enter twice. And because I'm printing out, I'm saying print the word, colon space, definition. We get back apple, colon space. The usually round red edible fruit, small tree, blah, 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 banana, colon space. And there we go. So you've access to the word and the definition in the same loop using .items. You're going to see this come up over and over and over again. You're going to be using for loops all over the place. This is one of the most common ways you're going to see it. So remember your enumerate function and remember your .items function. So now I'm going to shift gears and talk a little bit more on the practical side of for loops and some of the most common types of data structures you'll see in the wild. everybody uses lists and dictionaries to represent certain kinds of data. And one of the most common ways to use lists and dictionaries is a list of dictionaries. Let me show you exactly what I mean. So let's think of a spreadsheet of people. So let's say you've got, an Excel spreadsheet, and in your spreadsheet, you've got these column names. You've got a first name, a last name, and an age. Super simple spreadsheet. And you've got 3 entries in your spreadsheet. You've got a column of first names, a column of last names, and a column of ages. So, behind the scenes, this is what the data might actually look like. In fact, this is how the data would probably be represented if it were loaded into a web browser, because this is how a computer understands things. The column gets repeated every single time. So we get the column header, the column header again, and then the value. So for each of our rows, we have a dictionary. And for each of our columns, we've stored it in a list. So our first dictionary entry here, we've got first name Jim, last name Fowler, age 24. There's our entry. Again, first name Bob, last name Jones, age 36. There's our entry. So each row gets stored as a dictionary. Because we're not saying column 0, column 1, column 2. So you can imagine we could number these, right? This could be column 0, column 1, column 2. Instead, what we're using is these headers in order to index the column. A dictionary makes sense here because we're going to say column first name, column last name, column age. Okay, so this is our list of dictionaries. But let's actually do something with our list of dictionaries. And in order to do that, we're going to copy it into Python. Here we go. There's our data. Now, quick aside, because I actually missed something really quick. This structure is super important. This is called JSON. You may have heard it before. You may have not heard it before. But it is the preferred way to send data over the web, as I put it. In reality, it's a really, really nice, readable way to structure data. If you've heard of XML, XML was the old way to structure data. It involved a lot of tags. It actually looked very similar to HTML. Nowadays, a lot of people are moving to JSON. It's, in my opinion, a lot nicer. It usually saves some space. You sometimes have to finagle it, but most languages support a JSON interpreter. And for Python, which is really, really cool, by the way, you can take JSON and pretty much turn it straight into a data object. And that's exactly what we've done here. We've literally taken this, a list of dictionaries, and turned it into a Python list of dictionaries. In JSON, these are not called lists or dictionaries. This is an array, and this is an object. That's just something to keep in mind. But for Python, we're going to stick with lists and dictionaries. So we've added our people to Python. All I did is I just copied the people equals, open square bracket, there's our people. Let's loop through our people in the same way that you might want to do something in Excel. So let's imagine you wanted to build a filter, and you said, hey, I want you to tell me the names of all the people who are over the age of 30. Well, we can do that pretty easily. We're going to grab our for-person in people, and we're going to say if person at age is greater than 30. So person is a dictionary, right? So for each person is a row, is a dictionary. In people, people is our list. So we're just looping through each item in the list. But instead of a string, it's a dictionary. So if person at age is one of our indexes, is greater than 30, then print, here we go, print person at their first name. So we're going to say person, here's our person object, at first name, space, person at last name is over 30. There we go. So I'm going to press enter twice. And we get Bob Jones is over 30. Alice Appleseed is over 30. So we have 2 people over 30. And you'll notice how we unpacked is the terminology for that, this list of dictionaries. We took in the list, we looped through each dictionary in that list, and we did something with each of the dictionaries in there. You're seriously going to see this kind of data structure over and over and over again. And just getting comfortable looping through each dictionary in your list and then unpacking that dictionary to do something with it is super important. But let's talk about another common way to represent data. So you can have a list of dictionaries, and that's great for representing something like spreadsheet columns. But what if we've got choices? What if we've got drop-down forms? Like here, I'm asking you to choose a state. I'm asking you to choose an emotion, right? So how could we represent a drop-down menu using Python? Well, it's probably not going to be a list of dictionaries because the list doesn't make a ton of sense. We have drop-downs that are named, state and emotion, and then each drop-down has a list of values. So this is actually a dictionary of lists. And it looks something like this. We start with our dictionary instead of our bracket up here. We give it a dictionary key, states, and then our states is a list of choices. Same thing with our emotions. It's a list of choices. So let's add this data to Python so I can show you exactly what's happening here. Okay, so we've got our states, we've got our emotions, and these are our choices. Now I've got some fun code for you to paste in here, so let's do this. I'm going to say state equals input, type the state you live in. All right, so here we go. Type the state you live in. I'm going to type Ohio. Next, we've got emotion equals input, type how you are feeling. How am I feeling? We're going to go excited. Enter. There we go. Okay. I now have a couple if statements here that we can work with. So if state in choices at states. One of the most common things you'll do with a dictionary of lists is validation. So we want someone to choose the correct state and to choose the correct emotion that's in our list. We don't want them to input data that isn't in our list. And so we're going to actually do an input validation exercise here where we say, here we go, copy that. Hey, if the state you picked, which you picked up here when you wrote your input, is in choices of states, so we're going to grab our choices and then grab our list of states, that's going to return back this list. So if our state is in this list, then print good state. Otherwise, print I don't know where that is. So let's press enter twice. And because I entered a valid state, it is in our list, we get back good state. The next thing we're going to do is the same thing with our emotions list. So if emotion in choices at emotions, print same. Else print not a valid emotion. Your only valid emotions are the ones that we have in our list. And press enter. I get back same because my emotion was in my emotion list. This is an important thing as well. So you can use in with your for statements, but I don't think I've talked about in for lists. So let's go back to our fruits list really quick. I can ask Python apple in fruits, and it will return true or false, depending on whether apple is in fruits. I can also say apricot in fruits, and it will return false because apricot never appears in our list. So that's just a quick way to validate whether something is in a list. But back to our dictionary of lists here, you can see how we could do really quick input validation for named choice fields, which is something else that you're going to see quite frequently. In fact, Python will do this a little bit when we talk about Django. But what I want you to understand is that there will be instances where you'll make, for example, an API call, and it will come back with something like this, where it will say, here are the valid answers, or here are the valid options for this particular data point that you're working with. So you're going to see this all the time. You're going to see a dictionary with lists, you're going to see a list with dictionaries, and you just have to know how to use a for loop in order to unpack those things. You also just have to know how to use if statement in order to validate them. So at this point, we're done with our interpreter. Go ahead and type exit, and let's move on to creating an API. All right, so now we're at the fun part. So we've done a little bit with for loops. You've learned about how some common data structures will be represented using dictionaries and lists. And you know how to unpack those dictionaries and lists. So let's actually build an API. And you've probably heard of APIs before. And most of the time, they mean just a web page that serves JSON data. So we talked about JSON data. It's just this, right? It's lists and dictionaries, the same way we've seen it before. And an API is typically something that just serves that data by itself. There's no HTML involved. There's no CSS, no JavaScript. It's just going to be the raw data that you would want to use. So let's build one of those. So we're going to open mysite/views.py, same one we've been working in. And at the very top, we're going to add a new thing. Instead of this Django in addition to this Django.shortcuts import render, we're going to add from Django.http import JSON response. Now, hopefully, this would be, this should be somewhat self-explanatory, but I've told you what JSON is, and this is just a JSON response object built into Django. So we can feed it a Python dictionary, and it will serve JSON data to a web browser. I'm going to go ahead and clean this up too. So I'm just going to throw, there we go, import, whoops, nope, there we go. Throw import random above there so it looks the same as what's in the docs. Okay, so I've imported JSON response. The next thing we're going to do is build our API view. So below our weather function, we're going to go ahead and add a new function. There we go. So def API request, so it's going to look the same as our weather request. We're going to build our people list. So this is going to be the same thing we used when we did our columns up here. So let's imagine, right, you are working in a database and you have a database of people. And your people are represented using this format. And you want to serve that data over the web to someone who wants access to your API. You don't want to give them direct access to your database. You'd rather they go through your web page. So you've got your data here, right? You've got your people. We're going to return this as a JSON response. And we're going to say, hey, the data you're looking for, quote data inside this dictionary, is our people. And here is our list of people. So you're going to save that. And at that point, there we go. Your API function is done. Django makes it pretty simple. As long as we have a JSON response, Django will take care of all the formatting and all the serving that we need to worry about. But before we can go on, we have to now give it a URL. So let's open up mysite/urls.py. Here we are. And underneath our weather URL, let's add a people path. So you can imagine, right, you've got a database, it's got a lot of columns in it, or you've got a spreadsheet, it's got a lot of columns in it. Maybe you've got multiple spreadsheets. It's not just people we're interested in. You're interested in addresses. You're interested in weather. Sure, you've got lots of data, right? So we've got a people path. And the people path is going to serve up our API view, but you might have a lot of views that serve this kind of JSON data. So for now, we're going to worry about people, but you might have a lot of stuff that does something like this. So we're going to stick with people, right? We're going to make our people path. Well, we've got our people path. That's really all there is to it. We're just going to run python manage.py run server. There we go. That's going to start our server. I'm going to control click here. We're going to pull up our hello, but that's because we haven't done /people. So remember, our URL path is /people. Right now, we're still at index. So even though we've added our people, our index view is still the default view. So we have to go up here to the top and type /people. And there we go. You've got your data inside a dictionary, and there's our list of dictionaries. Now, it's not nice and formatted the way we had here. So there's that caveat, but this data is now accessible, and we could read this data in. In fact, you could actually take this data from the browser, copy it. I can stop my server with Control-C and run a new one using Python and go, here we go, data equals that. Look at that, I just copied it straight out of the browser, straight into Python, and because Python dictionaries and lists look identical in some cases to JSON data, there it is. We can do the same thing we did before to unpack this, by the way. Since I've got my data, I can say, all right, well, first things first, I need to get the actual list out of my data, and I know that that's at data, so I'll say people equals data at data. So data, here we go, is our key for our list. Remember, this is a dictionary with a list in it. So we talked about that. And our data at data is our list of people. So if I do that and type people, now we've got our list. Well, now we've got a list of dictionaries. So I can say, okay, let's grab the first person. So if I say people at 0, there we go. There's our first person, first name Jim, last name Fowler, age 24. And I can loop through this list in the same way that I was able to when we wrote it before. I can say for person in people, print, and let's do, person at first name. Sure. There we go. Whoops. Fix our syntax error. Print person. Oh, there we go. Can't use double quotes inside. Or single quotes? No, I can't use double quotes inside double quotes. That's actually an important point, by the way. While we're printing something and we're using what are called these F strings, notice how I've double quoted this, and I've said, F double quote person open bracket. This has to be a single quote. It can't be a double quote because then Python thinks you're trying to end the string. Vice versa, this also won't work because it's 2 single quotes. If I have a single quote as the first quote, I need a double quote inside my single quotes. So I digress. Let's go ahead and fix that. So there we go. So printf person at single quote first name. Go ahead and close that out. Press enter. And we get back all our people. There's Jim, Bob, and Alice. They're all hanging out together in their lovely dictionary. So we've taken an API response, which is exactly what this is. We've copied it into Python ourselves, and we've extracted data from it. So at this point, you can, to some extent, take web data and use it in code. And this is going to be one of the most, important things you can do with Python. You're going to be doing this over and over and over again. 99% of the time, the data you need is on somebody else's computer. It's being served on a web page, and you're going to need to access it. Well, fortunately, 99% of the time, it's going to be in JSON. Now you can read in that JSON and manipulate it using for loops, using your in function. Everything you can do that we just talked about with regular Python lists and dictionaries can be done using JSON data. In fact, the next thing we're going to do is talk about how you can take that data without copying and pasting it and interpret it in Python without doing anything. So we're going to learn how to read in a website using Python itself. So let's do it. We have an API, right? But it's super annoying to have to copy and paste the same data out of our API every time we want to manipulate it in Python. Wouldn't it be lovely if Python could do that for us? Fortunately, there is a Python package for this. It's called requests. Now we have to pip install requests in the same way we pip install Django. And remember that a pip package, when you run pip install, is just someone else's Python code. Requests is a library that was built to handle web requests. It turns Python into a quote-unquote web browser. I can actually pull up the requests main page here. Here we go. Requests, HTTP for humans. So requests is advertised as this super easy to use HTTP Python package where you can run a GET request on something, you can get the headers, get the status code, get the text, you get the idea, and check that out. On the front page, they even have the r.json example, which is what we will be making use of in a second. But you can see they've got this built in. This is how prevalent JSON is in the web space. They've got it built in on the front page of their, requests advertisement here. So let's get back to what we're doing here. I'm going to go ahead and exit on my terminal exit on my interpreter, so I'm back to my terminal, and I'm going to pip install requests. Now, depending on whether you already have this installed or not, yours might look different than mine. In the video I have playing over here, you'll notice that when I run my pip install requests, it says there's a bunch of stuff about it being cached. I don't have any of these black bars. When you see these black bars, it means that there's nothing cached. There's nothing already downloaded it can use. It has to go out and actually download these files for the first time. So on this computer, I don't have them downloaded yet, so you'll see this downloading. Regardless, pip installs both cases, and if you don't see an error, again, you can ignore this warning. If you don't see a red error, requests has been installed. Let's give it a try now that we've got it installed. So type Python to go to your interpreter and type import requests. You shouldn't get an error at this point. If you don't get an error, requests has been installed successfully. And go ahead and run a requests.get on Google. Now, here's an important thing to note. When we built our website, right, we have these index, these functions like index and weather and API. And all of these indexes are defined by a URL path. So in order to get to them through a browser, we have to put in the correct path. We make what's called a GET request when we go to these paths. It's just GET. It's called a GET request, all caps. So requests.get is kind of mimicking what your browser does when you first go to, for example, google.com. Your Python code behind the scenes is saying, hey, Google, serve me the web content that you typically serve a browser. And I'm just going to save it as code. So that's exactly what's going to happen when we run requests.get https google.com. But you're not going to see the output. Instead, you're going to get back this response object. And in this case, it's a response 200. And you don't have to know too much about this, but do know that 200 means okay. If you see a 200, it means it read the data, no problem. We can actually check what that data is, by the way. So if I go ahead and run r equals, whoops, there we go, requests.get. I can't type tonight. There we go. If I type r, right, r is now just our response 200. And if I type r.text, here we go, bunch of garbage. But this bunch of garbage is google.com. There's our doctype HTML. There's our meta content. Here's our name. All this stuff is everything Google uses to render their web page. So now that you understand a little bit about requests, and you'll see that requests is literally just loading the HTML that's behind the scenes, let's use the requests library on our API, because we built an API. Let's read data from it. Type exit to exit out of my interpreter here. And we're going to make a new file called api.py. So let's imagine you're working on a project and you need to read in, for example, weather data from a weather API, because you're building a magic mirror and you want to read in the weather data so you can display it on your mirror in your bathroom. So where you would probably make a file similar to this and you'd call it like weatherapi.py. And in here, you're going to put all the stuff that relates to your API calls. And that's exactly what we're going to do. We're going to call it api.py, and in here, we're going to add everything that has to do with our API calls. So we're going to import requests. There we go. So there's our requests package, the same way we did it in the interpreter. The next thing we're going to do is generate our response. Now we're going to start with our index page. We're not going to call our API yet because I want to show you what it looks like. But we're going to assign a requests.get output to our localhost 8000 to the variable response. So response is going to hold the same thing that r held up here. So we did r.text, that's going to be what response is. And we're going to print response.text. Now, when we printed response.text for google.com, we got this whole bunch of garbage. You can take a guess as to whether your response will be more or less garbage than google.com. We're going to find out. At that point, save the file and just run, whoops, actually, I am going to do this. Run python api.py. It's going to hang for a second. And there's a reason it's hanging for a second. It's because you haven't started your server yet, and you're going to get this max retry is exceeded with URL. No connection could be made because the target machine actively refused it. I think I touch on this a little bit further down, but I'm doing it now. I'm going to do it again down there because it is important. When you see errors like this, read the errors, because usually it's something silly like, oops, I forgot to start my server. And that's exactly what we're going to do. I'm going to say python manage.py run server. There's our server, the same way it was working before. If I go over to my localhost 8000, not my people, there's our hello. Okay. server's working fine. We're getting a response back. What we're going to do next is actually open a new terminal. So in VS Code, you've got this plus icon here. I don't think we've used this up to this point, but I don't want to stop my server, but I have to type Python API.py in order to get it to run. But I can't type anything while my server is running. I'm typing as hard as I can and nothing's going to happen. You got to click a new, or you have to have a new terminal in order to run stuff. And to do that, we can click the plus icon and it opens up this new terminal. But fear not, your old terminal is still alive and well. It's in this dropdown. You can switch back to it by clicking this dropdown and clicking back up to Python. You can get back to your command terminal by clicking it again and clicking command. So we've now got two terminals and we can run multiple things at once. And that's exactly what we're going to do. We're going to type python api.py, press enter, give it a second, and there we go. We get back our doctype HTML, body, hello, body, HTML. Now this should look very familiar because if you open your my site templates index.html, it's exactly the same. So this index.html got served to your web browser, which in this case was our requests library, so our web browser. It got interpreted by the requests library, and then it got printed out using your Python script. So we've communicated data from one Python script to another using a web API, which is pretty cool in my opinion. But let's do something a little more powerful than that. Now we're going to work with that JSON that we had made before. So back to api.py, and we're going to replace some things. So the first thing we're going to do is replace our response. So we're not interested in getting our index. We're interested in getting our people. Because remember, our people, if I go to /people, is where our data is. That's our people data. We want to know our people data. So that's the first thing we're going to change. We're going to go ahead and type python api.py again, just to show you what's going on here. So here we go, python api.py. And instead of getting back our HTML, oops, I forgot to save. There we go. Saving is important. Python api.py, instead of getting back HTML, now we're getting back our JSON response. And you'll see what I mean by when we run a JSON response, when we do a JSON response, there's nothing else here. So normally there would at least be this doctype HTML stuff that would get automatically generated. But when we do a JSON response using Python, it's just the raw data. And that's super important because you don't want this extra stuff when you're just interested in getting back API data. You want the raw, unprocessed data. Okay, so we have our data now, right? Let's do something with it. This is the exciting part. We're going to have to use the JSON library for Python. Now, I told you before, right? You could take JSON data from the browser. In fact, we did this. We could copy it and we could literally paste it into our interpreter. That works because the symbols that the browser uses to represent JSON data happen to be the same symbols that Python uses to textually represent Python data. Unfortunately for us, this, even though it really looks like Python data, is not Python data. It has to be interpreted. Because behind the scenes, this is a big old string. Python sees this all as one thing, which means we have to explicitly tell Python, hey, I need you to go through this entire thing and turn it into Python data. Fortunately, someone has already written the code to do that for us. It's called the JSON library. JSON library will take JSON data, so this text response, and turn it into Python data, and it can also take Python data and turn it into JSON data. In fact, behind the scenes, that JSON response library is using JSON to do this. So let's show you exactly what this looks like. I'm going to copy this next section down here. So I've imported JSON. I'm going to copy this. Here we go. And I'm going to replace our print response.txt because I'm not really interested in printing the response.txt. I want to print the JSON data. All right, let's tear this apart. So we now have this people equals response.json at data. Let's just take response.json for a second. Response, remember, was our response object, response 200. And when we ran response.txt, we got back the raw text. But we took a look at the request's front page, and there was this mysterious function here, r.json. Well, r.json actually does all the heavy lifting for you. It takes that JSON data and it turns it into Python data for us. The reason we're specifying @data is the same reason when we ran this before. Remember when I unpacked this data by hand, I said I had to say data @data. So I literally typed like data at, oops, there we go. Data @data, like that. That's all this is up here. That's all this response.json @data is doing. It's saying, hey, turn this into Python data, but then get me the thing that's @data. And the thing that's @data, right, is our list of people. So give me that list of people. That's actually what I'm interested in. Then, for each person in those people, if the person at age is greater than 30, print person, first name, last name is over 30. So there we go. It's the same for loop we had before. It's the same, people, whatever that we saw before. All we're doing is we're taking it now from the web, we're turning it into Python data, and we're doing the same thing we did with it when it was normal, when it started as Python data. So, with all that saved, go ahead and run python api.py. And look at that. It behaves exactly how our old application behaved. Bob Jones is over 30. Alice Appleseed is over 30. So we can read data from the web. So you took data that was served by your API in another Python script. It was captured by another script. You read it in, and then you interpreted and did something with that data. So you've created an end-to-end API script, which is really, really cool. Now, up until this point, right, we haven't done anything with the JSON function. But what I want to show you is how there's no smoke and mirrors with Python. There's nothing that we're really, there's nothing special about this response.json function. So what I actually want to do is show you exactly what I mean about JSON, this text to JSON that we were talking about before. So I'm going to recapture that people at text for a second here. And I'm just going to comment this out. Again, you can comment using control// if you highlight multiple blocks, by the way, in VS Code. Very helpful. I'm going to print people. And then what I'm going to do is I'm going to run json.load s. So this looks like json.loads, but it's actually json.load s for load string people. And I'm going to assign that to a variable. So I'm going to say JSON people equals json.loads people. And then I'm going to print my JSON people. I want you to see the difference between these two. So here we go. Run my python api.py. Whoops, there we go. String object is not callable. And that would be because, where am I getting that? People equals response.text. Oh, not a function. Text is just a property. There we go. So rerun this. Okay. Look at this. Look, they look almost identical, right? But the keen-eyed among you is going to notice a couple things. So first of all, our JSON data, which is on the top. So this is just our regular web JSON data. They all use double quotes. Down in Python land, right, we've got single quotes. This is the first important difference, and it may seem small, but real JSON uses only double quotes. And that may sound silly, but that's true. JSON is not valid unless it uses double quotes. So JSON to Python does this interpretation for us, and it gives it single quotes since that's its preferred way of representing data behind the scenes. And I guess that's really the only difference you can see here, but I wanted to at least draw that distinction because there is a difference, very subtle difference between this and between this. Again, Python sees this as just a big string. You need something like the JSON library in order to work with this JSON data. And you don't need to import JSON to work with requests. I know I had you import it here, but the reason I had you import it and the reason I wanted to show you this is because sometimes you work with JSON data that doesn't come from the requests package, and you can't use the built-in JSON converter. It's important to know that there is one included with Python, and this is how it works. It works exactly the same way as response.json. So now I'm going to do this and say response.json people equals response.json and print response.json people. So let's save that and run that. And I want to just show you that these two look exactly the same. So you can choose. You can import the JSON library, and you can use the JSON library to interpret web data, or you can use the built-ins for any particular function that you're using. It's up to you. So with that, go ahead and type exit here, or if you're feeling particularly fancy, use the drop-down, click Python, Control-C to stop your server. And that's all we have. Look at that. I have a bunch of stuff in my terminal. That's exciting. That was back when I was typing. So that concludes day 3. You've now learned how to use for loops. You've learned how to read data from an API. You've learned how to unpack dictionaries and lists. And at this point, you could start scripting some fairly complicated API stuff. If you needed to work with someone's API, you've at least got the basics to start doing that. So that should be fairly helpful.